So again, we're just going to start filling in what we know. So f of x, actually in this case, g of x, is equal to, and then we'll just write a line. And then what do we know? Well, let's look at our point of discontinuity first. So this point of discontinuity happens at -2. So that means there must have been an x plus 2 in the numerator and an x plus 2 in the denominator. They cancel with each other. That's how we ended up with this point of discontinuity. So perfect. What else do we know? Well, we have a x-intercept at 1, 0. So that corresponds to a factor of x minus 1. All right, one more. I can also see that we have a vertical asymptote at x is equal to 3. So there must be a factor in the denominator of x minus 3. So there, we're really close, but then again, we just don't know what the stretch factor is. So we need to solve for a. I'm going to use the point 5, 4 to sub in for my x and my y values because that was the point that was given. So this would be 4 is equal to a times 5 plus 2 times 5 minus 1 over 5 plus 2 and then 5 minus 3. This is 4 is equal to, and then this would be a times 7 times 4 over 7 times 2. So now the reason why I wrote it out this way is because you can see this will happen quite often where those 7s, well actually it'll happen all the time on these ones, where there was a point of discontinuity where those 7s would cancel with each other. Okay, so then we have 4 is equal to 4 over 2, or just 2a. So then a is equal to 2. So we'll throw that back in up there. So then g of x is equal to 2 times x plus 2 times x minus 1 over x plus 2 and x minus 3. So next we will just write this in expanded form. So since we've done this a few times, I'm just going to skip to the expanded version. So we would end up with 2x squared plus 2x minus 4 over x squared minus x minus 6. And there you go. Now let's look at the range of this function. So let's think about the values that aren't allowed for y in our function. Well, we'd have this non-permissible value, so whatever y is at that point is going to be not allowed. And we also have a horizontal asymptote, and it looks like it's going to be at 2. And in fact it is, and we actually knew that already because the degree of the numerator was the same as the degree of the denominator. So remember, if they're the same, that the horizontal asymptote is at the leading coefficient. So we know that we have a horizontal asymptote here at y is equal to 2. So we're going to have to exclude 2. But now the one we do have to solve for is this hole, or this point of discontinuity. So how do we do that? Well, we take the simplified version of the function and then plug in our non-permissible value of -2 and then see what we get for y. Now, you can see why this isn't going to work if I don't use the simplified version. If I use this version and throw in -2, well, look what happens. We'd end up dividing by 0. So we can't do that. That makes sense. that was a non-permissible value for a reason. So what we have to do is do the next version, or the simplified version. So that'd be g of x is equal to, and then we're going to cancel the x plus 2. So we'd be left with x minus, or 2 times x minus 1 over x minus 3. And then at this point, we're going to sub in negative 2. So g of negative 2 is equal to 2 times negative 2 minus 1 over negative 2 minus 3. So this is going to be equal to negative 6 over negative 5, or 6 over 5. So now we know where this point of discontinuity is. This is at negative 2, comma, 6 over 5. So we have to exclude that 6 over 5 from the range. Okay, so now let's write the range. So the range would be y such that y cannot equal, well, it can't equal our horizontal asymptote of y is equal to 2, so it can't equal 2. And it also cannot equal 6 over 5.